your notes, okay? Make sure you have enough information. So we're looking at right angles. So in order for this stuff to be true, we need a right angle in our triangle up there. So go ahead and add the right angle in it. It somewhat looks like it's implied, but we don't really ever want to make that assumption. So everything you guys did in geometry about trig, sides, and angles related together was only true in right triangles. So your triangle had to have a 90-degree angle in it in order for any of the trig stuff to work. Okay? And so the trig ratios that you guys learned was that the sine was equal to the opposite over the hypotenuse, the cosine was equal to the adjacent over the hypotenuse, and the tangent was equal to the opposite over adjacent. Okay? So you learned these three ratios. Hypotenuse is usually pretty easy for people because hypotenuse is located where on the triangle? Across from the 90, right? However, adjacent and opposite are totally within perspective. So like if I stand in this corner of the room over here, that corner and that corner are adjacent to me, but that corner way over there is opposite of me, right? But if I move my location and I move over here, now which corner is considered the opposite corner of the room from me? Over there. So you really have to know which angle you're talking about before you guys can know in the triangle what is adjacent and what is opposite. So I'm actually going to, I know that's a little annoying, but I'm going to scroll this down a little bit, see if I can write up there to show you guys. Sorry, I have to put it all the way up, and then I'll let you guys copy the sign part down if you don't see it before. So we have our 90-degree angle in our triangle, and right away with the 90-degree angle, we know this side over here would be the hypotenuse. Now, just a reminder in geometry, we often use capital letters for the angles, and then lowercase letters to represent the side across from the angle. So if you see them refer to something and you're not quite sure what it's talking about. The theta marker is right here. That's like a Greek letter, theta, okay? We often use it for angles. You see it in physics, stuff like this. You'll also see it here. So they're really talking about angle A here. Because they're talking about angle A, and notice angle A is made up of this side and this side of the triangle, that makes this side over here the opposite from angle A's perspective. And that means this side over here that's touching angle A, that helps form angle A, that's not the hypotenuse, that is the adjacent. Okay? And that's why when you guys look at the ratios over here, you guys see that they wrote the sine of the angle is equal to A over C. They're saying if this is my angle, sine is opposite over hypotenuse, that's this side over this side. Okay? Cosine is adjacent over hypotenuse, so they said B over C, all because they were using this angle as the perspective. And then beyond that. So are we okay with this idea? Remember from geometry just the setup, that there was a sine, cosine, tangent, that they did use these words, adjacent, opposite, hypotenuse, okay? And then you guys have this like beloved SOHCAHTOA thing that you love so much. Yeah, is that right? How many people in here use SOHCAHTOA to help you remember the trig ratios? Yeah, see, majority overwhelming. Okay. Miss Hoffman, Shrinky Dinks, is that what she did with you guys? No. Mr. Huynh told you guys. Okay, so I hate SOHCAHTOA, but I'm totally okay if you guys use it. It's just a personal thing. Two reasons. Reason number one, caused me great anxiety. I have a traumatic experience with it, whatever. No. So my first year teaching, I was teaching geometry. Okay, and this kid came in my class, and he was like very proud of himself, and he's like, I've taken this class before. And I was like, I don't know why you want to tell everybody that, because here you are. But okay, like that's all right. Like we got to keep on, trucking. So then this kid would come in every day and like talk to me about whatever. Are we doing this today? Are we doing this today? And I was really new, so sorry, high schoolers, but you guys are sometimes mean to your teachers. Sometimes you have bad days. You don't mean to be mean. You're generally pretty respectful, but and new teachers, whether they acted or not, are generally like nervous. Okay, like I was like, oh my gosh, this kid's gonna know more about what I'm supposed to do than me because he's been going to the school. He took geometry last year. Like he's all into it, right? And so then one day he walks in and he goes, are we doing SOHCAHTOA today? And I, for a minute, just thought like maybe he mumbled and I didn't hear him right. And I was like, excuse me? And he was like, SOHCAHTOA? And I was like, is is he speaking a different language? Like, do I not know what is happening? So my anxiety level was like super, but I can't tell him that I don't know. Like, if I ask again, I'm going to look really dumb, and I'm supposed to be like the expert in the room. So I was like, not today. And then I was like, what the heck did he say? And I'm like going through all these things in my head. So I like teach whatever I'm supposed to teach in geometry. The period gets done. I like run next door to like my teacher friend, and I'm like, oh my God. So like, I don't know if I can do this. Like, am I doing the wrong thing? Kids are talking about things. I mean, he failed geometry, and he's just said something I don't know. Like, what is that? And she's like, what did he say? And I'm like, Soka something. And she's like, Sokotoa? And I was like, yeah. Like, does everybody know what this is except me? And she's like, oh, it's like sine is opposite over I was like, are you joking me? Like, that's what it is. It's like an acronym. And like, who even made up this acronym? Like, these aren't real words. Like, how does this help you remember the thing? Okay? Okay, so reason number 1, like, harbor inner resentment for that traumatic experience I had to experience. Reason number 2, no lie, maybe 4 years ago. Somebody raises their hand during test on this concept. Ms. Dahl walks over to them. What do you need help with? Okay, Ms. Dahl, how do you spell Sokotoa? So, problem. If the key, this is not real words, right? It's not like how do you spell game or something like this. I forgot how to spell. Like, these are not real words. Their sole purpose of being strung together is helping you remember the S goes with the O and the H. So if you can't remember how to spell it, how does that help you? Okay? So, totally okay if you guys like Sokotoa. All right? I'll smile while you guys all use it, because apparently all of civilization does, except for Ms. Dahl. But can you please remember how to spell it yourself? Because if you ask me during the test, I won't tell you. Because this was your choice right here. Sokotoa. Okay? I have another way to remember it. I used to think it was great, but I guess Sokotoa is right up there with it. Mine isn't even like, it's not even something special. You actually have to remember some of the things. So that's no fun right there, right? You have to know sine, cosine, and tangent, and then the letters just stand for something. But the sentiment you might like, it says, oh heck, because we're PG. Another hour of algebra. See? Isn't that cute? Don't you like that better? This makes so much more sense. Okay, whatever. So point being, whatever it is that you use, can you remember it and not walk into people's classrooms saying so really fast because it just sounds like something that doesn't make sense. Okay, are we good? We have some way that we remember trig ratios. Yes? Okay, and when Ms. Dahl goes like this a little bit, every time you guys say it, you'll just know. It's just me, it's not you. Okay? All right, so now we have to remember how to actually use them. So first, we're just going to write what the trig ratios are equal to. So when you're writing a ratio, you're just writing a fraction. So this one says, find the value of the 3 trigonometric functions for angle theta. So that just means 3 things. Sine of theta, cosine of theta, tangent of theta. Did they say to find the actual value of the angle? No. They said, find the value of the trig functions. The trig functions are equal to the fraction that you set up on the other side. Okay? So if you struggle with setting up the fraction, you should first go through and label your triangle. It should have a right angle in it, first of all. Sorry, clearly my little boxes did not show up. Which part of this triangle is hypotenuse? The 13th, so that I can label right away. And then adjacent and opposite depend on where theta is. So which side would you call the opposite? 5. Because here's the angle. It's made from these 2 sides. The one side that is not involved in making that angle would be considered the opposite. The sides involved in making the angle are the hypotenuse and the adjacent side. Okay? And this will be true every time you're using a right triangle, because we only take trig ratios of the acute angles, so not the 90. And so that's why you'll always have hypotenuse and something else making the angle. It'll be the hypotenuse and the adjacent side. So what would be the sine of theta? Somebody give me that ratio. We're just writing a fraction, reducing it if we have to. But that's it. Okay, so Emily says 5 over 13. Do you guys see? She's pulling out opposite and hypotenuse, right? So cosine of theta would be what ratio? Claire? 12 over 13. And tangent of theta would be what ratio? 5 over 12. Okay. So are we okay with the setup? If we want to set it up, Basically, this is just to build understanding. If I have a triangle, I have the ability to understand which side is which given my angle perspective. And I can set up an equation with 3 pieces. The angle would go here, and the appropriate side ratio would go here. Okay? Any questions on that side? No. Okay, so then we use these to either solve for angles. In this case, you would be solving for the angle. See how the angle is the only missing piece? Right? So this is enough information up here to solve for the angle with the help of a calculator. Okay, I don't expect you guys to be like human calculators. And then also to help us find side lengths in some other situations. Okay? People a second, because this is going to blink off the screen when I touch the little thing. All right. So then a couple of things about how to actually find them and their relationships. So the first one we're going to do just by sketching stuff and understanding what they're telling us with information. The second one is totally just, do you know how to use your calculator? And we'll figure out if we do or not. Okay? So the first problem up here says to find the tangent of A. So again, are they asking me to find A? Like, do I have to find the angle? No. They want me to write the tangent of A. So tangent is equal to what? Good. Were you guys thinking, oh, heck, another hour of algebra? Is that what happened there? No. Okay. So opposite over adjacent. Okay? So first I have to have a picture of a triangle with an angle A before I know what the opposite over the adjacent is. So this other section of information is supposed to help me build that. So I don't know everything, but I know if I do build a triangle and if I find angle A, the cosine of angle A breaks down to 2 over 3. So I'm going to just sketch for myself a triangle that's a right triangle and give it an angle A. And then for myself, to make sure I don't mess it up, I'm going to label the sides according to using angle A as the perspective. The reason I'm using angle A is everything in here is about angle A. Here they're talking about angle A. Here they're talking about angle A. So wherever angle A is, that's where I can base off of like opposite and adjacent and stuff like that. So hypotenuse across from the 90. Opposite is the side that doesn't touch angle A. Then the other side that helps form angle A is the adjacent. So knowing that the cosine of angle A makes some ratio of 2 over 3, and that the cosine is adjacent over hypotenuse, I can kind of go and label my triangles with those values. Now, they might have been different numbers before they became 2 over 3. This might be like a reduced version of the fraction. But that means the other numbers would reduce also, so you have the freedom to just use the numbers straight from there. So our cosine of A, our adjacent over hypotenuse, is 2 over 3. So now I have a picture in which I can go answer the question about putting together the tangent ratio. So tangent is opposite over adjacent. So opposite I don't know, but adjacent I have as 2. So I almost have this ratio. Okay. How will I find the opposite side? Yeah, Pythagorean theorem, right? Pythagoras, that guy. All about it, right? So I basically have to do 2 squared plus my missing thing squared equals 3 squared. 3 is the hypotenuse, so it should be the thing on the side by itself in the equation, right? It should be over here. And so I'm going to go ahead, do the best I can with what's here. So I get x squared equals 5. X is technically equal to plus or minus rad 5 in this equation, but the equation's about a triangle, so like positive rad 5. So rad 5 is the value for the opposite side, and so that will also be what I need to use in my ratio here. So the tangent ratio would work out to be rad 5 over 2. So is everybody okay with how we process the information? First of all, because they were asking for tangent of A, we just knew we had to set up the ratio for a tangent, okay? Opposite over adjacent. Then we needed a picture to do that with, so we used the cosine of A to set up the picture. Okay? Any questions about this? All right, so take out a calculator that you'll probably be doing like homework or class. I honestly don't care if it's the calculator on your phone for like homework or classwork. I think they're more difficult to use personally, but like whatever. But on tests, obviously, I'm not going to let you break out your phone and use the calculator. Some boundaries somewhere. So this example 3 down here says to find x. So this is the first time they haven't asked us to set up the ratio. So before it was like, what's tangent of a? Well, tangent of a is this little ratio or fraction that I set up. But now they're saying actually find x if you know that the sine of x is equal to 0.7590. Okay? So we basically want to use inverse things. So you guys know that when you're solving equations, if 3 is multiplying x, you guys divide by 3 because that undoes it. That's because multiplication and division are inverse operations. But then you also know it gets more complicated than that. If an equation has an exponent, it's exponential, like we were just doing in the last unit, and you needed to solve it, and you needed to get x out of the exponent, what did you have to do to an exponential equation? So when you guys had something like this, 2 to the x equals 3, what did you guys have to use to try and undo the exponent or get it out of the exponent spot? Logs. We had to rewrite it with logs, right? That's because exponents and logs are inverse operations. So in the world of trig, you have your sine function. Your sine takes an angle, like the angle from the picture, and tells you what the opposite divided by the hypotenuse turns out to be. However, if you want to find the angle, if you want to get it by itself, you can't just divide by the word sine. That has no value. It's a function like log and stuff like that. You have to do the inverse of it. So there is an inverse sine function defined on your calculator. So on your calculator, if you see the sine, cosine, tangent buttons, above it in another color, like where you push the shift or the second button, there should be sine with a little -1 next to it, something that looks like this. This exponent of -1, when it's on a function, means inverse. Okay? So that's sine inverse, cosine inverse, tangent inverse. That's notation for that. If you guys are using your phones, if you turn it like landscape style, it gives you a scientific calculator. You don't see it right away. If you're in the right mode, you just see sine, cosine, tangent. But if you push the second button, then you see sine inverse, cosine inverse, tangent inverse usually. Okay? So what we want to do basically to undo this is it's like we're taking the inverse sine of both sides of the equation. Kind of like taking the log of both sides of the equation when you're solving an exponential. And then the log helps undo the exponent. Here, sines and inverse sines are opposite operations, so they undo each other. So like this one undoes this and leaves us with x. Okay? Here, this is a calculation we need the calculator to do for us. And the calculator basically has like a database of all of the sine values for different triangles. And then it just like goes through that database and says, which angle turned out to be this? Which angle has a sine this? You guys might have even seen them before, like back in the day. When you guys didn't bring calculators, like before my day, okay? When you guys didn't bring calculators to class, there's tables, and it has like a list of angles, and then it tells you what the sine is, what the cosine is, and what the tangent is. So what you guys would be doing right now is you'd be looking through the sine column, like, oh, there's the closest number to 0.759. Which angle did that come from? That's what the calculator is doing for you. Okay, so it's saying, I know you got this sine, which angle made that happen? And then you get your angle value. So go ahead and see what you guys got. We might get some different answers depending on the mode that your calculator's in, so we'll check that by seeing if our answers are the same. If you're using your phone or a calculator that works like that, you may have to type the decimal in first and then type this to get it to do it. If you have a calculator that lets you type in everything you want before you press enter, you type it in just like you see it. Okay? No, we can just round to like 1 decimal place for this case because it's an angle. A lot of times they might even have you round the angles to the whole degree. So you should get 49.4. Okay, and that's degrees. How many people got maybe like a weird number, like point something something? Okay, so you're probably in radian mode instead of degree mode. We want to be in degree mode because we're dealing with angles that we've measured in triangles as a degree measurement. So on your calculator, there's a mode button right next to the blue second button. If you push mode. If you're using your phone, down in one of the corners, there's usually a button that says DEG on it. If you press that, that will put you in degrees, and then the button will change to say RAD. If you push it again, it doesn't mean you're rad. It means it's going to change it to radians, okay? So basically, we need to be in degree mode, all right? And I'm going to get you guys started on a problem after this, and then those of you that are still struggling with not being in the right mode, I'll come around and look at your specific calculator and help you with that, okay? Is that all right with everybody? Just a reminder about how to kind of undo the sine function so that you can figure out the angle value, okay? Any questions about this stuff? So we can still use Pythagorean theorem to set up missing sides, and we have an inverse sine. So if we're solving for something that's inside of a sine, cosine, or tangent function, we'd have to use an inverse sine, cosine, or tangent, okay? All right, so what we want to do is basically solve triangles. So when it just says solve the triangle, that means find everything that's missing. A triangle has 3 angles and 3 sides. So in the end, if you've solved a triangle, you would have all 6 pieces of information, okay? So in this case, to finish solving our triangle, there's only 2 things that are missing. I'm going to keep a little list of them over here so I know when I'm done solving. Basically, I need to find the measure of angle A and the measure of angle B, and then I'll be completely done solving the triangle. Okay? So it doesn't matter which one of these we solve for first. Okay? What does matter is we don't have enough information just about the angles to find these 2 angles right now. Right? I can do 180 because that's the amount of degrees in a triangle, minus 90, and I'm left with 90, but I have no idea how to split it up for these. Okay? So that's not enough. That's how you know you have to use sine, cosine, or tangent, because you want to use the sides to help you find an angle, or if you want to use an angle to help you find sides, that's what like the wonderful world of trigonometry does, that you can step outside of just having to do angles or just having to do sides. They're like related to each other. Okay? So what do you guys want to find first, angle A or angle B? It doesn't matter. Angle A. Okay. So we're going to focus on angle A. Okay? That means if I'm looking for angle A, I want A to be my variable. So remember, for all the sine, cosine, tangent functions that you guys did, I'm just going to kind of write, I don't know, this isn't even anything here, but kind of helps you remember. Whatever you're taking sine, cosine, or tangent of, in here you have your angle. And on the other side, whether it's opposite, hypotenuse, adjacent, you have 2 sides of the triangle. So if you're going to set up a trig equation and you want it to be solvable, there's 3 things that you need to fill in. If it's going to be solvable, only one of those things can be kind of empty or x or your variable or whatever it is you're looking for. So you guys just said that we want to focus on finding angle A. So our angle is going to be A. That's going to be the thing that we're looking for. So if we want this to be solvable, we're going to have to include both sides. Which triangle, they've given us all the sides, so that shouldn't be a problem. Okay? So then I have to decide which sides I'm going to use and whether I'm going to use sine, cosine, or tangent. Okay? So in your groups right now, decide on an equation that you guys could use that would help you solve for A. Okay? There's lots of answers to that because they gave you all 3 sides of the triangle. So try to write an equation, a sine, cosine, or tangent equation where A is the angle, because that's what you're looking for, with the appropriate over here. What's an equation that can help you solve? All right, so you don't have to solve it yet, but what's an equation that one group do you use that's going to help you find A? Genevieve? Okay. So tan A. So what'd you guys get over here? Okay, so this is one option. Tangent of angle A, which would be opposite over adjacent, could equal 12 over 9. Okay? Did any other groups come up with a different equation that they were going to use to help them solve for A? Candy? Okay, so what did your equation say? Cosine of A Okay, so if we look over here, cosine is adjacent over hypotenuse. So cosine of A is equal to 9 over 15. Okay. So this problem, you guys kind of had 2 options. You could have decided which 2 sides you were going to use. Like, you know what, I'm going to use 9 and 12. and then you're like, oh, those are the opposite and adjacent, so I have to use tangent to write the equation. Or because they gave you all three of them, you honestly could have set up any of the sine, cosine, or tangent functions for angle A, and all of those are solvable. Okay? So let's say I take this first group suggestion and I solve this equation. In order to get A alone, because it's inside of the tangent function, I have to use that inverse tangent. So every time I'm solving for an angle, you'll see that I have to use the inverse because the angles are always trapped inside of like the sine, cosine, or tangent function. So I'm doing that inverse tangent to both sides of my equation. So these two will undo each other and leave me angle A on the left side. And on the right side, I need my calculator to tell me what inverse tangent of 12 over 9 is. And so we'd get 53.1. Okay. And if you did inverse cosine of 9 over 15, you get the same thing. If you did inverse sine, you'd get the same thing, because all of those are ways that we could have set up equations to find angle A. So for angle A, we get 53.1 degrees. And then how are we going to go find angle B? Do you have to use trig? Oh, look at what you know right now. Okay. Dylan? Yeah. Perfect. So we'll add angle A and angle C together. And then because a triangle has to have 180 degrees, we'll just subtract those from 180 and we'll have what's left for angle B. Okay, so you don't have to use trig all the time. You have to use it till you have enough information to get what you need. Okay. So in that case, you should get that angle B is 36.9 degrees. Okay. Is that okay with everybody, how you can use trig to help you find missing angles in the triangles? So the next triangle is going to have more stuff missing, okay? And we're going to let you guys see as far as you can get with solving, and then we'll see if we can figure it out. Just making sure. I know when I click it, it takes it off the screen, so I'm just trying to make sure you guys all have it before I leave. Anybody still need the screen? All right, so this is the last one that we're going to do for today, okay? So we're going to see how far you guys can get. And so basically, in this triangle, I'm going to label a couple different ways. So first of all, this is called angle X, which means across from it, I can call that little x, and across from angle Y, I could call this little y if I want just one letter to refer to those sides. And to solve the triangle, you guys have multiple missing things to find. You have one missing angle in angle Y, and you have two missing sides. They could name this side right here, this side length xz, or they could use little y. Okay, but either way, that's referring to this side here. The other missing side is over here, which they could label as capital Y, capital Z. Okay, that means the length of the line that's connected by those 2 points, or little x if they used that notation. So you have two side lengths and one angle to find before you're done solving this triangle. Okay, so see how far you get, and then we'll check in. I'm not going to do the whole thing yet, but some of you are struggling with the setup because of, it's not exactly like the last one that we did, right? So if you just haven't seen it for a while. So first, finding your angle should be relatively easy, the missing angle, because the angle should add up to 180. This time you have two of them, so we should get 27 degrees for our missing angle. Okay, just by adding up the two that were there and subtracting it from 180. And then can somebody give us one of the equations that you use to find either x or y? Some setup, some equation that can either find x or y. Genevieve? So Pythagorean theorem is a good idea because when you're finding side lengths, you can find them. However, the obstacle here is when you set it up, it'll say x squared plus y squared equals 23 squared. If we can have one more value for x or y, then we can use Pythagorean theorem. So we're going to have to use trig to either find x or y, but then we can totally use Pythagorean theorem and not have to use trig again. Okay? So we figured out we have to use trig first to either find x or y. Candy? Okay. So if you're struggling with where to go at that point, like you don't know what to focus on, here's what you should do. Pick one thing you want to find. So let's say I had picked x. I want to find x, right? And remember what we had talked about. All the trig functions, whether you use sine, cosine, tangent, they have an angle in here. And on the other side, you need two sides to set it equal to. By deciding that you're going to find x, you've just said one of these things over here is going to be x, okay? So one side is going to be x. Whether it's top or bottom kind of depends on how you set up the equation. But that means that your other side and your angle need to be numbers that you know, or else you're going to end up with an equation with too many variables in it and you can't solve it. So then you have to pick an angle to focus on. So let's say I say, okay, I'm going to do everything from the 63-degree angle. Once I decide I'm going to use my 63-degree angle to help me find x, the only other side length here, which is what I would need to complete this, right? I have an angle. One of my sides is x, and I need another side. But I need it to be a number because I'm already using x in the equation. So I have to use 23. So when I look at this picture, if I'm using this angle to help me find x, and I'm also going to have to use 23, label the pieces that you have. The 23 is the hypotenuse. And if I'm using this angle, the x is opposite. So then I see why, if I'm going to use this angle, x and 23, I have to use sine and not cosine or tangent. Because if I'm going to use this angle with opposite over hypotenuse, the only ratio that uses opposite over hypotenuse is the sine. Okay? And then for solving this, so you guys struggle a little bit because if x is in the denominator, you guys have a hard time. So you really just have to multiply by 23. But for those of you who really, really, really struggle with this, okay, you can always think of this as a ratio. Okay, like just put this over 1, and you can cross multiply like we've done for a lot of other things when we were solving at the beginning or on some of the stuff on our weekly review. So you can see 23 is going to multiply the sine of 63. And 1 is going to multiply x and just make x. So this is how we'll get our answer. Okay, we'll do 23 times the sine of 63. And the sine of 63 is some crazy decimal that the calculator knows. Okay? And we're not expected to know it. When you multiply them together, you should get, if we round to the nearest tenth, 20.5. Okay. And then you guys can go ahead and find the third side of the triangle, and you guys have a couple of options of how to do that, and then we'll check if... Right, how many people are using or used Pythagorean theorem to help them find the third side of the triangle? Okay, so a few people. So if you guys set that up, you should have had the 23 on the side by itself. And then 20.5 is the other side length we found. And then we could solve that equation. Okay. How many people went and used trig to help you find the y value? Okay, so if we used trig, if we wanted to use the same angle we used before, and the side that was given, but this time we want to solve for y is the adjacent side to that angle. So one option for this to use adjacent and hypotenuse would be cosine. So we could set up cosine of 63 equals y over 23. Okay? And we could solve it that way. So I'm going to give you guys what the decimal value should be for that other side. And then depending on the method you use, it might vary a little bit. So I'll tell you, like, if I use this method, I get that y is equal to 10.4. If I use Pythagorean theorem, I get 10.4. So either way, that seems to work okay. But sometimes your answers will vary a little bit depending on how many times you had to round or whatever before you set up your equation. Or like if some people found y using the 20.5 side instead of the numbers that were given, theirs might vary a little bit because that was a rounded value. But it should be close enough that we can tell. And I'll always look back at what you did if I feel like yours is close but not the same as mine to see if it's coincidence or if you guys were solving it correctly but you just rounded differently or used different values to solve it. Okay. So does this give you guys a decent overview of your all the stuff you did in geometry? Okay. And so right triangles, we're not going to do anything else